Okay, so now we're going to talk about operations with matrices. And when we mean operations, we're going to talk about adding matrices, subtracting matrices, multiplying. Now there's actually going to be two types of multiplication, and the reality is we're not going to talk about division. And the reason for that is that division is not defined for matrices. You can't divide matrices. There's reasons for that beyond the scope of this course. I'm not going to go into that. So let's start off here with just talking about what do we mean when we have equality of matrices. Well, we often use capital letters as a side note to represent matrices. So for instance, what do we have here? Let's let A and B be two matrices. I could spell matrices correct. A equals B if A and B are of the same order and Aij equals Bij for all choices of I and J, which literally means they are just going to look the same. And as a kind of a silly example here, just to illustrate this here, if you had 4, -1, 2, and 0, this is, of course, the same thing as I could write this matrix as 8/2, -1, square root of 4, and 0. Now, they look maybe slightly different, but we shouldn't see that they're too different in the end, because 8 divided by 2 is just 4, and then square root of 4 is 2. Same size, and the elements are all the same. So, pretty obvious, I think. Alright, now let's talk about adding here. Adding matrices. Well, first off, let's talk about how this is. So if A is equal to, and this is a way to write a matrix, A subscript ij, and B is equal to another matrix, and we'll say B subscript ij, are matrices of order m by n, then their sum is a matrix of order m by n given by A plus B is equal to Aij plus Bij. So adding matrices is literally going to be just adding the respective elements of rows and columns together. So nothing too difficult here. Let's look at an example here. Let's just add the following two matrices together. So add these two matrices together. Well, the first thing I should note here, and it should be obvious from the definition, and this is the case here, is in order for addition to be defined, the matrices have to have the same order. Meaning that you can't add matrices that are different sizes or different orders. Alright, so again, this is pretty straightforward here. Kind of belaboring it a little bit. You just add all of the elements together like you would normally. So you have 4 plus 2, because this is row 1, column 1, row 1, column 1. So 4 plus 2, which is 6. Negative 1 plus negative 1, which is negative 2. 2 plus 0, which is 2. Negative 3 plus 6, which is 3. And then that's it. So really just adding the numbers together. Alright, so we're going to move on now to scalar multiplication. You might say, well, what about subtracting? Well, subtracting is really just adding a negative. So if we think about scalar multiplication, we can just do the subtraction. Plus, it's pretty obvious if we're just adding the elements together. For subtracting, we literally would do what? Well, we subtract them. So let's look at scalar multiplication. Now, scalar multiplication, this is where we're multiplying a matrix by a single number. And that single number is what's referred to as a scalar. And if you've in some science classes or when you start getting into other math classes, basically the difference between a scalar is you have something that's called a vector and a scalar. And a scalar is just like a number. A vector is something that has a length and a direction. And so that's why we use the term scalar. Alright, so if A equals Aij, then C times A is just equal to C times Iaj. So what we're literally doing is we're just multiplying every number by C. So let's look at a quick example here. Let's let A equal 3, negative 1, 2, 6, negative 5, 1. And then we want to find out what 5A is. Well, that's 5 times the matrix 3, negative 1, 2, 6, negative 5, 1. And so again, that's literally going to be 15, negative 5, because I'm just multiplying everything by 5, 10, 30, negative 25, and 5. Now, I didn't put the square brackets here. Yeah, you'll lose points for that. That's not a matrix. A matrix has brackets around it, and they're square brackets. Okay, so but that's all we have to do with scalar multiplication. So let's look at one more example here of what I would consider kind of basic operations, and then we'll actually end this video because matrix multiplication needs really just its own video, because it's not, I think, difficult, it's just odd. It's not at all following your intuition. So let's look here. We have A equals 4, negative 1, 0, 4, negative 3, 8. B is equal to 0, 4, negative 1, 3, 1, and 7. And so we're going to be asked to find a couple things. We're going to ask to find A plus B, 2A, 3b, 2a minus 3b. Now all of these are pretty straightforward because again these operations are what I would consider pretty basic operations. So we have 4, negative 1, 0, 4, negative 3, 8, plus 0, 4, negative 1, 3, 1, and then 7. And so this is equal to, well, 4 plus 0 is 4, negative 1 plus 4, positive 3, 0 plus negative 1, negative 1, 4 plus 3, 7, negative 3 plus 1, negative 2, 8 plus 7 is 15. So again, not really much going on there. Most common mistake I see people not being careful, making arithmetic mistakes, and on problems like this it's hard to kind of give partial credit for those kinds of mistakes because all you are doing is arithmetic. So it's kind of hard to give a lot of partial credit on these types of problems. Alright, so let's look at then 2a. This of course would just be 2 times 4, negative 1, 0, 4, negative 3, 8, which of course is just going to be the matrix 8, negative 2, 0, 8, negative 6, and 16. And then we want to look at 3b, which is 3 times the matrix 0, 4, negative 1, 3, 1, and 7, which is 0, 12, negative 3, 9, 3, 21. Now the last thing we want to look at is 2a minus 3b. And that's not coincidence. Notice I had us find first 2a and 3b. Whenever you want to do something like 2a minus 3b, what we're going to want to see is first computing what 2a is and what 3b is, and then doing the subtraction. And so we have here 8, negative 2, 0, 8, negative 6, 16, minus 0, 12, negative 3, 9, 3, and then 21. Now, only thing we have to be careful of here is, of course, our signs when we're subtracting. 8 minus 0, well, that's easy enough. That's just 8. Negative 2 minus 12, negative 14. 0 minus negative 3, 0 minus negative 3 would be 0 plus 3, so that's 3. 8 minus 9, negative 1. Negative 6 minus 3, negative 9. And then 16 minus 21, which is negative 5. So not difficult, just stuff though that we have to be a little bit careful with. Alright, so as I said, this kind of wraps up the first video on matrix operations. We're then going to talk about matrix multiplication. And as I said, matrix multiplication is a little unusual at first. So let's end this video here.